sketch a graph of g of x equals cosine of x and find its local and global maximum and minimum values if they exist. To sketch a graph, we'll need axes. So let me grab us some axes. Whoop. And we know that the cosine function has a range from -1 to 1. And we know that it is nice to label our x-axis with multiples of pi or pi halves. 3 pi, 4 pi. And then we'll go in the opposite direction. -pi, -2 pi, -3 pi, and -4 pi. Just want to draw an ample amount of the graph so that we can look at what's going on. Now, we recall with cosine of 0 is 1, so we can start the graph there, and then we know that we've got basically a sine wave. We go down until we get to pi, and then we go up until 2 pi, and then down until 3 pi, and then up until 4 pi, etc. And it is an even function, so it is symmetric about the x-axis. So we're going to continue that pattern over here. And it's not the world's greatest graph, not the world's greatest drawing, but it is what it is. It's good enough for our purposes. We want to find the local and global maximum and minimum values. And we can see that we have a whole bunch of maximum values. And because the function is periodic, we know that they're going to be repeating. And these are both local and global maximum values. We know they're global maximum values because cosine is never greater than 1. So wherever it's equal to 1, that is the maximum value. And so we can start writing this out. We have global and local maxima of 1. That's the function value. That is the maximum. And this occurs when? It occurs at 0. It occurs at 2 pi. It occurs at 4 pi. If we were to keep going, 6 pi. Also, -2 pi, -4 pi. So all of the even multiples of pi, and the way that we can write that is 2 pi k for k, an element of the integers. This might be something you've never seen before. And if this is a homework problem somewhere, it might not actually require this notation, but now is as good a time as ever to tell you what the notation is. If we have something that is occurring periodically, then we can write what that period is. The period is 2 pi, and then we can put a k in front of it for all integers k. This is k is an element of the integers. And that means that k could be 0, or k could be 1, or k could be 2. And so this occurs at 0, at 2 pi times 1, which is 2 pi, at 2 pi times 2, which is 4 pi. Same thing with -2 pi and -4 pi. This notation might be a little bit more complicated than you will see in your textbook or in your class, depending on which textbook you're using and which class you're taking. This is the formal way to do it. The informal way is to say just at all multiples of 2 pi. Now, those are the global and local maxima. We can also talk about the minima, which you can see we do have. And we know that those minimum values are -1. So of -1. And when do they occur? Well, they occur at 1 pi, 3 pi, 5 pi, negative 1 pi, negative 3 pi, basically the odd multiples of pi. Now, the way that we write that, because we have an odd multiple of pi, it's going to be 2k plus 1 times pi for k, an element of the integers. We could also distribute that pi, and we could write this as 2 pi k plus pi. Either way works. This is a formal way of writing odd multiples of pi.